Bob now has his fish, and so he's looking for a fishbowl. That is, he wants a function that takes his fish, which has a size field with a number, and then, takes care of his fish and perhaps reports how healthy his fish is as a number. So Bob says to Alice, I need a fishbowl. Alice says, here is a bowl specially made for colorful fish. It takes a fish that has a color and it monitors the color as well as the size, and combining that information, it tells you how healthy your fish is. Now, is Bob going to be happy with this bowl? No, he's not, because he doesn't have a color fish. This bowl can't monitor his fish's color. It may think a gray fish is ill and just crash and just kill off his fish, and so he's not happy with that. And this is a little counterintuitive because the colorfish bowl looks fancier than the bowl that Bob wanted. It's got this extra decoration here. But in fact, the subtyping relationship doesn't work out. It turns out that general bowls that work for any fish, from the perspective of someone that has a fish, those are more rare than bowls that have to have a color fish. Because if you've got a color fish, you can use this kind of bowl or this kind of bowl. But if you have a non-color fish, you can only use a generic kind of bowl. So the subtyping relation does not hold in the same way that it did when we changed the result, right? And it's because we're changing the argument to the function instead of the result to the function. Here's another example that illustrates that in code. Here I've got a function f that wants another function g that's supposed to work on records that have an x field. And g is supposed to return us a number somehow from that record. And I'm calling f on this other function, which is like the one that only works on colorfish. It needs a record that has an x and a y. And this function is going to look at the y. And you can see if we try to run this program, then it's going to go wrong. So it should be rejected. And the way we see it's rejected is that this function type for the argument g, that's not a supertype of the type of the green box here, the one we actually give it, right? That this function type with extra fields in the argument record, that function type is not a subtype of this other function type. Okay. So we don't want to make a change that allow that. We don't want to change this tau1 here to be able to be a subtype of tau1 over here. On the other hand, let's say that Bob says, I need a fishbowl for my blue fish. I've got a colorful fish. I want a bowl that works on color fish. And Alice says, I've got this bowl that'll work on any fish at all. Will Bob be happy? And yes, that bowl can somehow take care of a color fish without having to look at its color. It can just monitor its health well enough. And so Bob is going to be happy in this case. And then we can formalize that by saying that this function type that wants a fish is a subtype of wanting a color fish. And we can look in code and see the same sort of thing. So here, f takes a g that is supposed to work on any record with x and y fields. Here I'm calling f with a function that takes a record r, but this function needs the record to have an x field only. And everything's going to go fine. When we call g on a record with x and y, this function will get the x out. There will be an x, of course, and so it'll return 1, and the whole program runs to completion. So again, it's that this argument type with a record with x and y returning a number, that should be a supertype of a record just having x. In other words, a function that wants a record with x is a subtype of a function that wants a record with x and y. And we can formalize this by taking our subtype on functions, where we had formally generalized just tau2, and we generalized tau1. And you should see that tau1 prime is subtype of tau1. That's backwards compared to the part below. Alright, so it's a little bit counterintuitive, but you've seen from examples and from the fishbowl analogy why things work out this way.